This is Chapter 9, Solutions, and Section 5 is Dilutions of Solutions. Dilution is a very common process when it comes to dealing with solutions. It involves adding some solvent to increase the volume of the solution in order to decrease the concentration of the solution. So the solution goes from more concentrated to less concentrated when you dilute it. So making orange juice from a can of orange juice concentrate is an example of this, right? You take a can of the concentrate, you add several cans of water, and you mix it together, and so the original concentrated solution has now been diluted into a more drinkable form of orange juice. Okay, so we're going to learn in these slides in this video how to describe this process and how to calculate the outcome of this process. To deal with dilutions, there's a few facts that it's helpful to remember. So a dilution, again, is the addition of solvent to a solution. Okay? Usually the solvent in this class is going to be water because we're dealing mostly with aqueous solutions. So we add the water and the volume increases. Okay? And as a result, the concentration decreases because the number of particles is staying the same. Okay? We've added solvent molecules, but we haven't added any more solute particles. So because the volume increases, but the solute particle stays the same, in the concentration formula, the denominator is increasing and the numerator is staying the same, and so the concentration will decrease. Okay? The solute particles are spreading out. They're becoming more dispersed throughout the solution. Okay? Here you can see in the top, they're all bunched together. Here in the bottom, you've added some more solvent, and so they're all further apart. So in the initial and diluted solutions, the amount of solute remains the same. Whether you want to measure the amount in terms of moles or mass or number of particles or whatever, the amount remains the same. Okay? And you can always determine the amount of solution from the concentration and the volume. Okay? So remember, the concentration of the solution, C, equals the amount of the solute divided by the volume of the solution. So we can rearrange this and solve this to say that the amount of solute in a solution is equal to the concentration of the solution multiplied by the volume of the solution. So if we have two different solutions that have the same amount of particles in them, then they're going to have the same product, C times V. So in other words, we can take the concentration initially and multiply it by the initial volume, and that's going to be equal to the final concentration multiplied by the final volume. Okay, we've obtained this formula, this equation, by relating the amounts of solute particles, which stays the same throughout the dilution process. So this is the dilution formula. Okay? Sometimes you'll see this written as M1V1 equals M2V2 because frequently we measure the concentration in terms of molarity, and so since capital M is the unit for molarity, some people express it this way. But it's really more general than that. You can use any concentration unit you want. So I like to keep it as C1V1 equals C2V2. Okay. So this allows us to answer questions like this. What is the final concentration when 0.50 liters of 6 molar HCl solution is diluted to a final volume of 1 liter? So when we analyze a question like this, we really have to interpret what it's saying. Okay, it's asking us for the final concentration, and it's specifically telling us that they're diluting some concentration. So this allows us to recognize that we should be using the dilution formula. Okay, a lot of students are very eager to use this formula in a lot of different solution questions where it's not necessarily applicable. Okay, it only applies to a solution being diluted from one concentration to another. Okay, or from one volume to another. So if you're talking about one solution and it's not undergoing some change, then this equation doesn't really apply. Okay, so you have to make sure that you're actually dealing with a dilution situation in order to apply this formula. If not, then it's much more useful to go back to the original concentration formula, that the concentration is the amount over the amount of solute divided by the amount of solution. Okay, that's going to be useful in a much broader range of situations. But this problem is a dilution problem, so we're fine. Okay, it gives us the initial concentration. Okay, 6 molar HCl is the initial concentration, that's C1. The initial volume is 0.50 liters, that's V1. And it tells us that it dilutes this solution to a final volume of 1 liter. Okay, so it doubles the volume from a half liter to 1 liter and wants to find the new concentration. We can take the dilution formula and rearrange it to find C2. This is the value we're looking for, so we can just divide both sides by V2. and that will cancel V2 on the right-hand side, and so we'll end up with C2 equals C1 times V1 over V2. Okay? Again, we sort of collected the volume units together to recognize that that unit has to cancel. So luckily we were given them both in liters, and so that'll be fine. And then we just put what we need in. The C1 is 6 molars, V1 is 0.50 liters, V2 is 1.0 liters. So again, the liter units cancel out, and we're going to be left with the molar unit. Okay, so 6 times 0.5 over 1 is going to be 3 molar HCl. So the new concentration of the solution after it's been diluted is 3 molar. Okay? So if you look at it, we can see that we doubled the volume, and so we cut the concentration in half. Okay? So the same factor that the volume goes up by is the same factor that the concentration is decreased by. Here's another example. What volume of a 2% mass over volume HCl solution can be prepared by diluting 25 milliliters of 14% mass over volume HCl solution? Right? So we are going to be diluting 25 milliliters of a 14% solution. So this clearly is going to need the dilution formula. So let's analyze the problem. We have the dilution formula, and we know the initial concentration is 14%, right? So we're diluting this solution, so it's 14% and 25 milliliters. Those are the initial properties. And then we're trying to make a 2% solution, but we don't know how much we'll be able to make. So we want to know the volume V2. Okay, but we do know that the final concentration should be 2%. Okay, so we're somehow going to increase this volume until the concentration drops to 2%. Okay? If we want the concentration to go down, then obviously the volume is going to have to increase. So we're going to have to add more solvent to make the concentration go down. We can, again, just rearrange the dilution formula. This time we're solving for V2, so we divide both sides by C2. Okay, cancels out on that side, and we're left with this. Again, bringing the common units together. In this case, it'll be concentration units. Okay, so we have percent M over V for both concentration units, so that's going to cancel out properly. So when we put it in, we have 25 milliliters initially, 14% is the initial concentration, 2% is the final concentration we're aiming for. Those percentages cancel out, and we end up with 175 milliliters. Now you have to be a little bit careful here because sometimes these questions are asked in a little unusual way. So here the final volume of the solution is 175 milliliters. But the question might say, how much solvent do we need to add to dilute it to a 2% solution? And in that case, because it's phrased a little bit differently, we would have to recognize that if you start at 25 milliliters, then to get to a final volume of 175, you really only need to add 150 milliliters. Okay? So you take your 25 milliliters of 14% solution, and you add 150 milliliters of water, and you end up with 175 milliliters of a 2% solution. Okay? So in this case, we don't really need to think about it that way, but sometimes questions will be presented that way, and you have to account for that. Here's another example. We'll go through this quickly. What is the percentage, mass over volume percent, of a solution prepared by diluting 10 milliliters of 9% solution, sodium hydroxide, to 60 milliliters? Okay, so the initial volume is 10 milliliters, the final volume is 60 milliliters, the initial concentration is 9%, and they want us to know the final concentration. So we can collect all this information together when we analyze the problem, rearrange the dilution formula, this time to solve for C2, and then just put in your values. So 9% times 10 out of 60, the milliliter units cancel, and we get 1.5% final concentration. Now let's do one for molarity. It says, what is the molarity of a solution prepared by diluting 0.180 liters of 0.600 molar nitric acid, HNO3, to 0.5400 liters, or 0.540 liters. Okay. So again, the initial volume is 0.180 liters, the final volume is 0.540 liters. The initial concentration is 0.600 molar, and we're looking for the final concentration in molarity. We can collect all our information together. We know that if the volume is increasing, then the concentration should be decreasing. Okay, so we're going to use the same formula, and we should get a decreased concentration. Then you rearrange the dilution formula to solve for the final concentration, C2, and then you put in your values. So C1 is 0.600 molar. The initial volume is 0.180 liters. The final volume is 0.540 liters. The liter unit will cancel out, and you'll be left with the same concentration unit that you originally had. And so we'll end up with 0.200 molar concentration. That's the final concentration once you've diluted this solution.